I recently ran a poll on Twitter. I want to share the results with you guys here. The question was, by your best estimate, what percentage of display ads are already using imagery generated by tools like DALL-E and Imagen? If you don't know what I'm talking about, you need to immediately Google avocado chair and go down the rabbit hole from there. You might be able to get yourself a DALL-E account or a Midjourney account, or download the open source Stable Diffusion and run that locally. The breakthroughs in text-to-image are pretty amazing. Oh, but the results. Actually, before the results, let's talk a little survey design. I had to come up with the answers. I gave 4 possible answers. First answer, 0%. Then I had to take a risk here because I didn't know how people were going to vote. I said less than 1% as my second category, 1 to 5% as the third, and anything greater than 5% as my fourth category. 8.3% of respondents said that they thought 0% of the ads they were seeing were generated. I don't know, maybe they've got ad blockers on because I'm starting to see these. Entirely coincidentally, I presume anyway, 8.3% also said greater than 5% of the images they're seeing they think are generated. So what about the middle? 12.5% of responses said it was between 1 and 5%, which leaves remaining only our most popular category. 70.8% of all the respondents said they think between 0 and 1% of the ads they're seeing online are likely using imagery that was generated by an AI. I should run this again in 6 months and see what happens then. And what about the sibling language models, things like GPT-3? Perhaps my poll should have inquired how much text data that you see do you think were generated by AI? I don't think I have a good sense of that. That's much harder to notice, at least at this point. Now, I don't think long-form New Yorker articles or The Atlantic or places like that are going to use GPT-3, but maybe for coverage of small sporting events, or how about creating job ads? We discussed the feasibility of that in today's interview. It is well established that GPT-3, trained on biased data, has bias in its output. The last thing you want is a biased job ad, so if you're going to use a tool like GPT-3 to generate a job ad, or really to generate just about anything, you should have a mechanism for debiasing the results.
My name is Conrad Borchers, and I'm a current first-year Ph.D. student at the Human-Computer Interaction Institute of Carnegie Mellon University. Yeah, so I actually just started out in Human-Computer Interaction Ph.D. My background is originally in psychology and data science, so I'm very happy now to merge the two with my doctoral studies.
Yeah, can you talk about that journey? You could have done well with those degrees alone. I wouldn't describe this as a pivot, but certainly a unique choice, I guess. What was the path like?
Sure, yeah. So I suppose it was a pretty linear path if you think about it retrospectively, but I guess that's true for all life stories in some sense.
Yeah.
So I suppose I always wanted to become a teacher growing up for some reason. And then when I ended high school, actually, one of my teachers greatly discouraged me from doing it. And I'm not ungrateful for that. So that actually motivated me to look a bit broader with regards to what I can do to improve educational systems and processes. So that kind of got me started on research, on educational inquiry with regards to science and current research. And then I essentially figured out psychology is a good avenue to pursue that type of work. Then I studied the bachelor's degree in the south of Germany. So I'm originally from Germany. Then recently discovered, or maybe discovered along the way, that I really like programming and statistics. And then I got in touch with researchers that kind of merged data science with educational research, which is primarily in the US and under the names of learning analytics and educational data mining. So then I pursued a master's degree to kind of sharpen my toolbox. And like you said, I could have stopped there, but I eventually realized I really do like to do research and write and think very critically and in a very nuanced way, I guess, around data and research issues. So then I applied for a grad school in the US and ended up here, and I'm very happy it worked out for me. Carnegie Mellon is great for learning technologies. They developed them here for, I think, close to 30 years or even more. So yeah, that's about it.
Well, I'm curious, where along the lines did you first take an interest in natural language processing?
So I guess in my earlier works during undergrad, we did a lot of sentiment analysis to study social media data, particularly how teachers use it to connect with other peers and kind of improve their skills. So that kind of got me started because we had some trouble regarding validity and kind of these different measurements, because you can essentially sentiment analysis, which is the study of classifying or quantifying emotions from texts. So that could be one definition. You essentially have access to a broad range of different tools you can use. It's not exactly clear which one you should use for different data sets and contexts. So I kind of researched that. We did a little conference poster regarding which measure to use in educational contexts. And then when I went to Oxford for my master's, I enrolled in a natural language processing course. That kind of got me started. Got in touch with the AI Society there and thought, hey, this is great. They actually allow someone with not a full history of AI publications to kind of learn in a very intense way how research is done in that field. And that's actually how we then ended up doing our conference submission to NACO and the workshop paper we're discussing today.
Well, before we get to that paper, I wanted to hang a little bit with sentiment analysis still. I know that's one area that has undergone, one might even say, a revolution in methodology. Could you comment on how the techniques and their usefulness have changed from the time you started working with sentiment analysis to the present?
When I started out, we essentially used dictionary-based approaches where you would essentially just count up words in a sentence. Like, let's say I say, the weather is great today. Then maybe the dictionary would match the word great to a positive sentiment and then arrive at the conclusion that the text or the sentence in question is positive, right? Then there are other approaches that kind of weight words. So great might be a stronger word than nice, for example. But obviously, when we look at these larger language models and fine-tuning of these larger language models, we can see that some of the classification performances on these texts are actually remarkably outperforming these more crude approaches. And that's particularly the case because they can pick up more complex interrelationships, I would say, between words within sentences. So, for example, irony might not be the best example, but we might be able to pick up on more nuanced linguistic markers like that with models like GPT-3 that can be used for classification, as you may be aware. So I suppose I overheard a conversation the other day at the School of Computer Science here, and actually one person in line said, hey, actually few-shot learning and fine-tuning is the way to go for everything at some point. So that seems to be the broad direction that we're headed potentially.
Yeah, at some point, I think in the earliest days of sentiment analysis, we would, as you described, look at keyword features maybe in some statistical sense. But you were always, I guess, going to run into problems with a sentence like, this has been my greatest defeat. Things like that could throw off your system. Are those days gone, or do the new models make similar mistakes?
Yeah, I would say in some sense yes, in some sense no. I had a really great professor in Oxford, Janet Pierre-Humbert, who described it like this. So she essentially said, with regards to these larger attention-based models, they are like a very old child that has listened to all sorts of language, so thousands and thousands of hours of language, but can't speak. So essentially, we have models that have a very good understanding of what text is out there and how to reproduce it and maybe play around with it. I think DALL-E 2 is another great example that kind of picks up, which is an image creation model for those not aware. So you essentially prompt it with a sentence and then it can essentially create all sorts of images also within the styles of Picasso, Van Gogh and others. But it is essentially not able to kind of transcend what it has already heard. So that's kind of the analogy that my professor drew there with the child that can't speak, right? And then there's all sorts of problems that might come along with that. So I suppose in our work, we've been trying to pinpoint the issue of bias in the training data these large language models have been trained on. So when you listen to thousands and thousands of hours of language, which might be text that you train the model on, that might also encode some of the underlying biases or inequalities that society tries to transcend or maybe mitigate. So that could be one problem. I guess in terms of accuracy, I can't speak to that, but I know that there are still incremental So in natural language understanding, you have all these different benchmarks, right? And there's definitely still progress that is made there, but the question is whether we can actually achieve that with even more larger models. So I will leave it at that, I suppose.
Yeah. I'm wondering if we could explore that bias and maybe expand upon it, give a few examples. What does it look like to detect a bias in a large language model?
When we started out on our project, we probably took a couple of weeks to months to actually think about and clearly define what bias actually is. And I think after doing the work we have done, I'm probably even less confident in my personal definition of it, or I would say there are many different viable definitions. However, when you look into the literature, there have been different attempts to quantify it on a model level. So, for example, with these large language models, you have often underlying word embeddings, which are vector semantic representations of words. And you can, for example, quantify the words man and woman as the prototypical gendered words. You can actually project different words and their vectors onto a space that is spanned by the female and male vector, and then see essentially how they relate, so how gendered they are essentially, with which gender they are associated. And then you can think about, for example, if a model like GPT-3 produces text, what are different words that are maybe associated with gender stereotypes in this text, and how does that relate to, let's say, a particular target domain that you want to generate text for. So let's say you want to generate a job ad for a carpenter, which is the example from our title. Then you might come up, so the model then might come up with words that are particularly connotated or associated with a male gender stereotype, for example. So that's one way of quantifying it. But I personally would say, as a psychologist, I have a little bit of a different idea how we might go about it, but I will probably stop there.
A strato is business intelligence that helps you get back to business. As a progressive data leader, you need to be sure that you and your team have the best resources. Having the right tools makes it quicker and easier for you to get the right insights at the right time. A strato is a modern BI solution brought to you by the experts at VizLib. Purpose-built for the cloud, a strato is the next-generation solution for intelligent, accessible data analytics. With a strato's approachable, no-code solution, you can do more than just empower your team. You'll be able to facilitate quick and easy adoption across your entire organization and ensure that everyone in every department has what they need to answer critical business questions. Your team can enjoy unprecedented opportunities for invaluable collaboration with Astrato's intuitive creative experience. And their integrated write-back functionality enables you to write, edit, and comment on your data without ever leaving your business app. With Live Query, you can explore big data instantly and enjoy greater agility, performance, and security. Best of all, you can try Astrato for free. Visit astrato.io/dataskeptic to sign up. They've got a collection of example workbooks you can try in the cloud or get started with your own data. Visit Astrato, A-S-T-R-A-T-O, astrato.io/dataskeptic. Thanks to our sponsor, ClearML. ClearML is an open-source MLOps solution users love to customize. It helps you easily track, orchestrate, and automate ML workflows at scale. Machine learning is no fad. Your organization is only going deeper on investment. Don't let this be a source of technical debt. ClearML can improve every step in your ML workflow, making it a tool loved by data engineers, ML engineers, DevOps people, and data scientists alike. ClearML is hands down the best collaborative ML tool with full visibility and extensibility. As a contributor on a machine learning team, ClearML amplifies your efforts. As a manager, ClearML gives you the transparency and metrics to guide your team's efforts effectively when you can't get pulled into the weeds. Their solution logs your entire process. Your data and models are versioned, so there's no questions of provenance or audits that can't be done. Model repositories give you a clear view of available binaries, and you can deploy pipelines directly from code. Supercharge your entire development process. Go check out ClearML today. Visit clear.ml to get started. So the research in your paper is about debiasing, And you begin from a starting point with the knowledge that these large language models, this has been proven, but these large language models, they have bias baked right in. And your effort is really to measure and to counteract it. So from one framing, I could say your work is like a downstream effort. We could also spend time upstream trying to, regularize the training algorithm or finding better stratified data sets, things like that. Do you have any thoughts on how to split our efforts across the upstream and downstream fronts?
That's a great question. And I would even add another layer of complexity there, if you allow me to.
For sure.
I suppose I think we really have to ask ourselves in the very first place, what is the societal issue or the societal entity that we want to improve upon, right? So why is it in the first place that we want to tackle bias? And I think having that end goal in mind, depending on how we define it, potentially you want to say equality of opportunity, opening the landscape to different genders equally so that everyone can kind of unfold their talents is one potential goal that we can have as a society. Then the question is, what are these biases doing that currently prevent us from actualizing that ideal? And one of the works that Gosha and colleagues did, which we heavily built on in our project, they essentially showed how likely it is that different genders, particularly men and women, would apply for jobs if they read job advertisements with these stereotypical words, with specific words. And then you can measure essentially, this is where the psychology lens comes in. We really like these operational definitions. So what is the manifested behavioral effect, right, of these different words? You might say one proximal goal that we can set in order to actualize the larger societal goal is to maybe have equal probabilities of applying for a particular position. But then on the model level, I think you can also address it as a more holistic problem and try to ask, what can we do with regards to the training data or with regards to the model debiasing procedures to maybe steer and shape the current practices of these models to serve that larger societal goal. And obviously that's not straightforward since there are so many steps in between and mediators. So we have to constantly check, is what we are doing actually doing something that helps us achieve that goal? Which is a very pragmatist notion, but my personal take on this at this point.
Yeah, you mentioned some good points that there is a real harm here. It's kind of a question a lot of skeptical people ask, what's the harm in something like, I don't know, believing in Bigfoot or something like that? But here you say, if there are studies that establish people are less likely to apply for ads that are written in a very gendered way that doesn't match for them, then it's harm to that person and that they didn't get maybe a good opportunity. And it's also kind of harm to the company because they will either find a not as qualified person or wait longer to find someone. So there's like this a natural fix you could have here. If we could kind of get rid of that from the ad, it seems like there could be a big societal gain. Given some of the existing scholarship, is there a way to quantify that? Like how significant of improvement can we make with these efforts?
Mm-hmm. Yeah, let me first emphasize that I really like how you summarized it. I think that's exactly on point, and I think we really have to emphasize mutual interest here as well. So debiasing can essentially profit both the applicants but also the companies.
Win-win.
Mm-hmm. So your question essentially was, maybe you can briefly remind me here.
Yeah. I guess if we look to some of the existing scholarship, like the case you mentioned, right, or anecdotally, I've heard there's cases where two identical resumes, but the one with the stereotypically white name gets more responses than the stereotypically African-American name. Mm-hmm. No one likes these concepts, or that society works this way. But given that there's some measurement around it, what's the opportunity here for improvement? How much of a gain can be made for society?
Yeah, measuring this is extremely complex, I would say. And some of the problems we stumbled upon when we designed our research is that we actually don't have, for example, data on gender proportions in applicants. So you could, for example, have a simple model where you say, so the baseline expected gender distribution for a particular job is the current composition of that job. So let's say 60% of carpenters are male, or probably more than that, but whatever. Then you would say you would also expect 60% of applicants to be male. But that's often not the case. However, we don't have the data on that. And for example, with companies like LinkedIn, they might potentially be able to speak to this more. We had one student at the Oxford Internet Institute that collaborated with LinkedIn. However, there's also a legal problem attached to it, because on the one hand, it's not allowed for companies to advertise with regards to particular genders. And also, when you apply to jobs, it is not commonplace to also indicate your gender on the application. However, like you pointed out, from our common sense, we can definitely distinguish different names, so we can ascertain the probability with which someone is, for example, a US citizen or a foreigner or has a particular gender. So the question is, how do we grapple with that, essentially? And I would say when there's not a lawful way of dealing with it, because you might not want to change these laws, right? You probably don't want to mandate applicants indicating their gender, because that might have other ramifications and come with different problems. You might want to calculate or project for companies actually their current practices, or have these A/B tests like you mentioned, and then have HR people being included into a reflection on their current practices. And also another problem is when you look at the psychological literature on application selection. A lot of companies, particularly very sought after companies, have very, very high selection standards, because essentially they only want to have people hired that can do the job really well. And we can say from a statistical point, you have false positives, false negatives, right? Mm-hmm. And you have true positives and true negatives. The problem there is, we know from a statistical point of view that increasing the cutoff essentially almost eliminates the probability of a false positive, but that comes at the detriment and at the large increase of the false negative rate. So we also have to ask ourselves what we want to do with regards to false positives, or whether these might in some ways exclude, for example, certain populations more than others. So for example, there is this often quoted study that looked at women being less likely to apply for jobs when they don't fulfill all the prerequisites or all the required skills listed in the job ad. So I think what we can do is a mix of maybe a quantitative perspective on it, like you suggested, maybe evaluating what are the real losses in terms of diversity, or maybe even economic losses if we were to quantify them, if we could. But yeah, I suppose it's tough. Yeah, I don't really have an answer to that question.
Well, many years ago, I was actually when I was still an undergrad, I had a college job where I was helping somebody do some real estate stuff, and we tried to post an ad that said walking distance to the subway in Chicago. And they had us correct it. They said it should be close to a subway, because walking is somewhat, I guess, discriminatory to people with mobility issues. And we obviously didn't mean that. We were happy for the suggestion, made the change, all was well. So I think that was like a good outcome. Do you think there's opportunities here for technologies like GPT-3 to do similar things, to help people come up with better, in particular, I guess, job ads?
Yeah, there are different examples of this, actually. So when we did our research, and by that I mean doing our homework with regards to knowing what's out there, we stumbled across a startup or early stage company called Textio, for example. That Textio essentially helps HR in different companies to essentially analyze their current job advertisements, but also internal HR documents, to analyze them essentially for language that might, for example, discourage different populations, but also exclude them. Like you mentioned, it's also implicit or subtle things that we don't really realize day to day. And without our intention, that could, for example, discourage or discriminate certain populations. Yeah, so GPT-3, like you asked, could help to identify certain words. However, another thing I want to point out here is that we constantly need to evaluate the models we are using as well. So that is kind of the side note that I made with Textio initially. So for example, in my field, in educational research, there is a lot of grading algorithms for essays there. And if you took the GRE, did you take the GRE at some point?
I did, yeah.
Yeah, so there, for example, in order to reduce workload, they essentially have a computer or algorithm score the essay part and then have another human annotator score it. And for example, what we've seen there is that in more earlier stages of such algorithms, you could easily trick them by essentially throwing in a juxtaposition of highly infrequent or eloquent words, then get a high score. And now if you imagine we would not have someone in the loop that kind of monitors that. So this is for me a prototypical example of how algorithms could go wrong. We, on the one hand, might not be able to see these loopholes in algorithms, but another example my statistics professor used is we might forget in all what a good essay is if we kind of dispose with the human skills in terms of essay grading. So I think this might be in some ways applied to these text editors as well. So we have to constantly work on, in my estimation, our definition of bias and the effect it has in order to make sure that it has the societal effects that we want to see in the long run.
Well, I have to assume listeners to a podcast called Data Skeptic have heard of, maybe even tried talking to GPT-3 or some of these similar models that are out. Everyone knows what it is. So no doubt I could get GPT-3 to write a job ad for me, but also in like an uncontrolled way. Like I'm worried it might start talking about unicorn scientist or recipes or something like that. Do you have to do anything special to get the result you're looking for?
That's another great question. And you might have noticed that one of the things we evaluate in our study is the realism dimension. So we actually went ahead and annotated some of the results ourselves. And that's also how we came up with the title. So we saw that GPT-3 had a job ad called looking for a handsome carpenter with an eye for detail, I think. And there you have a weird mix. But we also had much more nonsensical examples, and they're included in the appendix of our paper. So I think there was at some point something like COVID-19, vit, and just going on like that. So something completely irrelevant to job ad writing. And even after fine-tuning it, so I think the remedy to this is in part to feed the algorithm with real-world job advertisements to give it a better sense of its structure. So we showcase in our study that this actually improves upon realism. But still, when we think about real-world applications, I don't really see right now that we will come to a place soon where we can just have GPT-3 create job ads and then essentially publish them live, like after, without having any human evaluator look at them, because there's always a small statistical probability that it might go at a tantrum or like do something.
Or promise a free car in one of the perks.
Right. So another thing what we see in news articles is one thing you can do is use template job advertisements. So you might not actually need such a complex model, but you can go with having a template where you essentially just fill the role name and salary and required skills. But I think that's not actually what we're looking for. I think what we're looking for is, and I think that's why we have so many startups that try to use GPT-3, is some sort of efficiency advantage. And I think that's we might get there. But I think we haven't really figured out as a field what is the most efficient way of using these models in a human complementary way, I suppose. Yeah.
Well, when looking at the bias in the different models, it would be great to have some sort of baseline or comparison to the real world. We all know the bias got there not because the algorithm's discriminatory, but because its training data was.
Right.
But can we learn anything from comparing some of GPT-3's results to the data set that you acquired for the project?
So with the data set we acquired for the project, so we actually compared, like you mentioned, real-world job ads compared to GPT-3 level job ads. We found that the baseline zero-shot job ads were more biased than the job ads that we found online. However, then, and this is kind of speaking to this, we then went ahead and selected some real-world job ad examples with low bias and essentially fed it into the model for fine-tuning, and then saw that the frequency with which these stereotypical words appeared was decreasing as a consequence. I'm sure there are other examples across different domains where you can find that GPT-3 might have this tendency to output more amplified ways of presenting information than you would maybe expect in job ads. So I think there was one study that looked at, for example, depictions or like associations, scenarios with regards to different ethnic groups and religious groups. And then one religious group was routinely associated with bombing, for example, which is something that is maybe a consequence of the training data being skewed towards these extreme events. So if you think, for example, about Wikipedia articles, or maybe as another domain, news articles, you might notice that they are incomplete or at least skewed representations of the real world. So you can potentially reason that this might be one of the reasons we see more stereotypical words in job ads as well. Yeah.
So earlier you'd made what I think is a pretty astute comment that we're at the point where people are trying to figure out how to deploy GPT-3 and DALL-E and similar technologies. It seems like, a great breakthrough has happened. Now what do we do with it is kind of the current phase of where we stand in 2022, at least.
Right.
And with that in mind, I'm curious if you could expand upon that fine-tuning and maybe share any wisdom for other people who are trying to fine-tune. What did you find effective or not effective?
So I have to caveat by saying the fine-tuning was led by my colleague Dalia. However, I assisted, for example, with the pre-processing. So one of the things that you will notice, fine-tuning might not be as accessible as it can be to non-practitioners or non-AI people. So I suppose OpenAI does a great job, in my estimation, in making it simple. But if you can't code and you can't really debug, for example, a JSON file being improperly formatted, then you might have a hard time figuring out the fine-tuning and kind of improve upon it. And I think that's a large limitation, because we definitely want to include domain experts that might not be as versatile with AI. But that's maybe a side note. So your real question was, what can maybe practitioners learn that are already familiar with fine-tuning?
Yeah.
I would say OpenAI has these recommendations online that says for classification or other endeavors, you should have that and that many data points. But one of my learning from the project is that selecting very carefully the fine-tuning data goes a long way, and you should maybe have a bias towards coming up with very good fine-tuning data before retraining the model. Really think about what your goal is and what you try to teach the model, essentially. That might be one way. And then, make sure to have an adequate sample size. That's what OpenAI outlines already. Another thing regarding fine-tuning prompt engineering in our study, and I don't really can comment on how that connects to other studies, was not really that effective when it came to the, for example, we prompted GPT-3 with essentially diversity emphasizing job ad prompts. So saying something like, write a job ad that equally appeals to men and women. That really didn't go a long way, potentially because GPT-3 couldn't really learn the mapping, or didn't really have an intuition regarding the mapping between these words and then words in the text. So fine-tuning might be the way to go with regards to the bias as we define it. However, carefully selecting the data, making sure it's properly formatted, and making sure it fulfills the bias criteria you set out to fulfill in the first place. Yeah.
Could you expand a little bit on prompt engineering? Even though I think it was sort of implicit in what you described, your paper was the first time I encountered this phrase, although I'm going to use it a lot because I hear a lot of people thinking this is the secret to using GPT-3. What the heck is prompt engineering?
That's a great question. And it's a curse of knowledge. You always just use these phrases.
Yeah.
And, great to stop here for a moment. So I suppose prompt is essentially the text that you put into the model, or the request you make to the model. And then engineering, I think it might be a little bit of an over-engineered term, if you allow me to make that pun, because engineering kind of implies that there's really a science behind it. You really
fair enough.
Think about every single word, but it's really about just designing the prompt in a particular way to kind of nudge the model. That's my personal definition to do certain things. So let's say it can be also a problem of under specification. So if I say write a job advertisement for a carpenter, obviously the model does not know what type of carpenter, like a British carpenter, a German carpenter, an American carpenter. Or you might engineer the prompt with regards to these nudges, right? So write a diversity-oriented job ad. So then essentially prompt engineering, I think, is the art of then looking how the outcome changes as a function of your input, and then adjusting the input as a consequence of what you observe. However, it's a fairly, and that's actually one takeaway I got from project 2, is that there's not really a commonplace definition or best practices, at least to the best of my knowledge, that kind of goes into the art of prompt engineering. And I think that could be a review paper to be written, or maybe even an article that kind of systematically compares them. But as you see, it seems to be something that is very much dependent on the model, but also the domain in which you test prompt engineering. So because we don't have access to GPT-3's model architecture, we can't really know how to do prompt engineering and what it does in different contexts. So something that works for job ads might not work for essay grading, might not work for other domains, right? So that's the problem here. Yeah.
Well, as you said, there's no methodological, engineering system of how to do this. It's more of an art than a science at this point, I guess.
Right.
So, I guess if I was trying to concoct a criticism, I could say, well, your efforts to debias with prompts or to encourage diversity, you just weren't clever enough. If you had been 10% more clever, you would have found out how to do it. Do you think that's a possibility, or are there just some tasks that the prompts are never going to help make improvements on?
Oh yeah, that's a great question, and I would actually like to explore that in some sense. So I just thought in the back of my mind while talking, could we do something like a grid search or a random search where we just systematically substitute words and prompts? So we set out with a particular template or set of templates for sentences, but we, as you rightfully pointed out, there might have been much more words that we could have tried. However, I would say from a practical point of view, it might not be worth the effort in the end. So every prompt, as you mentioned, and I think that's a problem with the application of these large models in general, they cost real dollar, and these models are pretty large to prompt. Fine-tuning in the first instance might actually go a long way, like we also showed with our results in the study. However, I could imagine if we come up with a science or maybe best practices to explore prompts, like I mentioned with the grid search analogy, or random search, or whatever search you want to do, that might be worthwhile. But yet again, it depends on the outcome, model, and context as well. So I suppose our work was pretty practitioner focused. And if you think about a company that tries to use GPT-3 for their HR department, there might be, we definitely need someone who writes up a study on this first, I suppose.
Well, as we touched on earlier, you had two goals. The sort of obvious intrinsic good was to see if GPT-3 could develop unbiased job ads. But then that other criteria you'd mentioned, it needs to be realistic, because if it's not, what's the point? Could you comment a little bit on the results through the lens of these two metrics?
So the takeaway from the study can be summarized as fine-tuning is on low bias ads is good from both of these lenses. So we observed in general an improvement in realism through fine-tuning on real job ads. But then when it comes to the bias dimension, there was this interaction where there was a much larger reduction in these gender-associated words when we fine-tuned on low bias job ads. However, prompt engineering was not really effective from both lenses. However, when we comment on realism here, I would still argue, even though our figure, one of the figures we included on our paper, might suggest that these ads are really realistic, that's still a judgment call that a classifier did. So I could imagine if you would have a more thorough annotation process, you would still realize very easily that the job ads cannot go into production like that, which is in part because the job ads we obtained for fine-tuning data are not properly formatted themselves, and we kind of obtained them as they were on the web. Yeah, so that's kind of the summary. And with regards to realism, I think the devil's in the detail. We have to think about either a further improvement in the fine-tuning data when it comes to formatting, maybe come up with a more rule-based algorithm to reformat some ads, or take out some, let's say, implausible sentences, so maybe just pre-screen some of the model output, or have another human in the loop that kind of checks them. pre-publication. Yeah.
Could you comment a little bit on how you measure realism? I don't know what the SI units are for it.
Yeah. Like I mentioned, or like I indicated a little bit, the method was, I would say, good for our purposes, but could be improved upon. So essentially, we had humans, so humans meaning people in our research group and friends that were familiar with the work, annotate some of the real job ads we gathered, and then annotate some of the GPT-3 job ads we created. But obviously the annotators would not know which one is which, right? And they would just make a binary rating. Okay, I think this is real. I think this is GPT-3 generated. And this is actually something that they did in the paper, I think it was called Language Models of Few-Shot Learners. I think they did a similar thing there. Because it's difficult to scale such human coders, we then just trained language model, which was done by my collaborator Hannah, and I think it was a GPT-3 based classifier. So we actually classified GPT-3 with GPT-3 with a GPT-3 classifier, which works, right? So it can, if you fine tune it, if you give it training data, it can outperform itself, which is something in itself to maybe acknowledge, which is cool. And then realism in the final analysis is the probability of the model saying, hey, this is a real job ad, right? So it will make a logistics smoothing where there's a probability between 0 and 1, and then you kind of set the cutoff for your prediction.
So yeah, I'd love to kind of reiterate that point in case some listeners didn't catch it, that basically you have these GP3 generated jobs and also the confirmed human jobs, which we know are ground truth realistic. Both of them can be converted into a vector with GPT-3, and that information alone is enough for machine learning to learn how to determine if something's realistic. Is that correct?
Yeah, I would say it can. So obviously, this depends on, like you mentioned, what do we define as realistic?
Well, human labels.
So it can, it can distinguish real and unreal job ads. But for me, the question is, does it really learn what we as humans define as a real ad, right? So it might pick up on, for example, and this is obviously one of the general problems in ML, that it might pick up on features that are pretty obvious but not really perceived by humans. So it might see that all the real job ads don't have any hashtags in them, or don't have any $sign in them, right? Or have maybe 2 carriage returns at the end. So that's something we haven't looked at, and I think that might be something to extend in future work, to maybe have some robustness checks on that model. But that's essentially how it worked. And it is definitely able to distinguish these human labels that we annotated.
Well, from this work, I think it's clear that these are useful analytical techniques, so there's definitely good reason to go on and be studying these language models in different contexts, and you have some of the methods and tools for doing that. Do you think it will remain, your work will remain in this somewhat passive mode of analysis, or will perhaps you achieve that goal of, let's just have the machine write the job ad and there's a human reviewer that's in the loop that just kind of makes a few corrections? How far away are we from the bigger dreams?
I would say we're not that far away. It's rather, for me, a question of logistics when I think about this problem. So we kind of need to connect, I would say, some of the research that is done to practitioners, maybe have these synergies going, and then iteratively identify what are the practitioners' needs, what are some of the advice that we as researchers can give, and then kind of improve upon that. Another thing is, and there's this article from a German sociologist called Theodor Adorno. So he, in his later years, returned to Germany after World War II, after an exile in the US. And he essentially had this interview with the German Spiegel, which is a very popular magazine here, political magazine, which states he does not fear the ivory tower. So I think there's something to say about changing practice through publishing certain types of work, through making the public and practitioners more aware of some existing problems, maybe suggesting ways of changing it. That in itself might have an effect, even though it might not be as measurable in the short term. But yeah, I suppose if we were to maybe connect some of the work to people in companies that work with job ads like Glassdoor or LinkedIn, that could go a long way. However, I think there are so many other interesting issues that we could go into, for example, in education with admissions. There's a very nice study that I want to maybe side note at this stage on cultural biases in motivation letters. So it's called Passion Matters, but Not Equally Everywhere. So that's a great, it's a great study on showing that, in some cultures, like in the US, conveying passion in a motivational letter is really important, but it might not be a cultural norm in other cultures. So as a consequence, these are potentially disadvantaged in grad school apps. Some fixes are easy. So for example, making admission committees more aware of that might go a long way. Other than that, it boils down to logistics and also the fact that short-term changes might not be measured as immediately, and some effects take time, particularly with regards to, societal change, I guess.
What's next in your work?
When you go to my profile online on my website, you might notice that, I might actually steer a little bit away from natural language processing work, and my Ph.D. will be with regards to educational technologies. So one of the data sets I currently analyze, which is an extension of Ken Holstein's work at CMU. So he developed these Microsoft HoloLens-based smart glasses for teachers that give them a better insight into how their students are doing in the classroom live, so that teachers can make more informed decisions about what students to focus on next. So one of the things that I want to grapple with in grad school is thinking about how can we align these technologies that make recommendations to serve institutional goals more effectively regarding maybe equity. It might be quality of opportunity, maybe helping talents flourish, right? So there are different ethical questions attached to that as well, but just helping to make maybe practitioners and institutions more aware how we can leverage these AI-based technologies could go a long way. So in some sense, I'm continuing the work that we've discussed today, but it has a little bit of a different suit, as we might say in German. So it comes in a different disguise, but still motivated by similar personal convictions, I guess. Yeah.
Very cool. And is there anywhere listeners can follow you online?
Yeah, thanks. So I'm on Twitter, Conrad Borchers, so first name, last name. My website might be the best way to start. It's cborchers.com, so clastname.com. There you can find all my socials. And I'm regularly posting updates about what I'm doing there. So and also feel free to send me an email. You can find my email address on my website too. I'm very happy to chat about research and anything else that you might want to chat about. So I think it's very interesting maybe to leave the listener with the thought of where else maybe biases might manifest and where we can do a better job at just thinking about how we can make selection, recruiting, advertising processes more equitable, fair, transparent. And I think all of us can maybe do a job in this by maybe sharing about this work, maybe sharing personal experiences, and talking to people that are sitting on admissions tables and then maybe making small incremental changes in that way.
Conrad, thank you so much for coming on and sharing your work.
Yeah, thank you very much, Kyle. I thoroughly enjoyed it, and I'm looking forward to tuning into your podcast soon.
That's it for today. If you haven't already, please join our newsletter by going to dataskeptic.com, scrolling down just a tad and filling in the box. Next week, let's discuss Facebook ads.
Sometimes they say, okay, if I privilege privacy, I'm going to lose revenue. But in this case, it's not the case. So I don't understand why they are not enforcing those limits.
That's next time on Data Skeptic Ad Tech.